So for section 5.2, we're going to focus on how we can find antiderivatives and the indefinite integral. So in 5.1, we were finding area under the curve. So now we're going to look at the rules for finding integration. So if we have a function f is called an antiderivative. Of a function f on a given open interval if f prime of x is equal to f of x. So basically the antiderivative is basically the reverse process of differentiation. You'll be given the derivative, and when you integrate, you're integrating the derivative, and what you're trying to find is the actual function who has that particular derivative. So if f of x is the antiderivative of f of x on an open interval, then for any constant c, the function f of x plus c is also an antiderivative on that interval. Moreover, each antiderivative of f of x on the interval can be expressed in the form of f of x plus c. So when you're integrating, we always have to remember to add our plus c, because we know when we do derivatives, the derivative of constants is 0. So that's why when we do our indefinite integrals, we'll be writing this plus c. So the process of finding the antiderivative is called antidifferentiation or integration. Thus, again, like I said, we're going to find the derivative of some function to give us f of x. So then by integrating or antidifferentiating the function f of x is producing the antiderivative of the form f of x plus c. So again, notice here's my integral of f of x. So this is my derivative. And we're trying to find the function who has that derivative f of x. And again, c just represents any constant. And again, these are two notations that represent the same fact. If I integrate x squared dx, then that's going to be equivalent to 1/3 x to the third plus c. You can always check your answers to see if you integrated correctly, because if you find the derivative of 1/3 x to the third plus c, it should get you back to your integrand of x squared, which if you take the derivative of 1/3 x to the third plus c, it does get you back to x squared. The adjective indefinite emphasizes the result that the antidifferentiation is a generic function, meaning you're going to have that plus c. The elongated s is the integral sign. Looks like that. The function f of x is the integrand. So again, that's the actual function inside your interval. We call that the integrand. C is your constant of integration. Again, you may have other variables used, so again, you'd have to adjust if you're using different variables. So again, the dx is sometimes absorbed into the integrand. So for example, 1 times dx may just be written as a dx, or 1 over x squared dx may be dx over x squared. So this page is actually taken out of your textbook. Again, these are all your integration rules for integrals. Just like you have differentiation rules, you have to know your rules for integration. So for example, we know the derivative of sine is cosine. So when I ask you to integrate cosine, the question you ask yourself is, what function has a derivative of cosine? That's going to be equal to sine x plus c. So your integral of cosine x is equal to sine x plus c. Again, because you know your derivative of x is 1, you're not going to see a 1 times dx written. So again, the question you're asking yourself, whose function has a derivative of 1? That's going to be your x plus c. So a constant, so some rules of integration that you use very similar to derivatives. You have your constant rule. So a constant factor can be moved in front of your integral sign, just like you can move constants out before you do derivatives. So if I have a constant inside my integral times some function, I can take that constant, pull it out of my integral, integrate, and then multiply by c. So that's going to be equal to my c times your f of x plus your constant. An antiderivative of a sum is the sum of the antiderivatives. That is, what I can do is I can integrate term by term. So that's going to be equal to f of x plus g of x. And you only have to write 1c one time, since again that just represents some arbitrary constant. So the antiderivative of difference is the difference of the antiderivatives. That is, again, you can integrate term by term, subtract each integral. So again, this is going to be equal to your f of x minus g of x plus your c. So some invalid theorems. There is no integral of a product. So again, if you have a product inside your integral, you cannot just take the integral of f of x and multiply it by your integral of g of x. And don't forget your dx. Just like there's no rule for quotients. If you're trying to integrate a quotient, you cannot just integrate the numerator and divide it by the integral of the denominator. So we'll learn other rules and techniques how to handle your integral of products or integral of quotients, but just know only addition and subtraction can you break up, not multiplication and division.